So now we're going to do analytic geometry, which is going to be question 3 and question 4. So let's start. So the first question 3 says, in a diagram below, the line BF, which is, let's go to the diagram, this is BF, right, is drawn from B. So it's drawn from B, which is they give us the coordinates to cut the x-axis at P and y-intercept at F, right? So they say the fact that the inclination of BF, which is the inclination of BF, which is beta, here is beta, and the equation for BF they gave us, this is the equation from A, which is 4, the coordinate is 4 is to K, there is a there. Then they say another line is drawn parallel to BF, right? So we know the fact that A is parallel to FB because they told us, and there's the parallel symbols to indicate the fact that they're parallel to each other. Then it says the line passing through A and B has an inclination of 45 degrees, right? So we know the fact that the line that passing through what? Through A and C has an inclination of 45 degrees, and it cuts through the x-axis at C. Then they give us the fact that what? ABF is theta. So let me erase this. So since all the information that they talked about is already in the diagram, now let's answer the first question, which is 3.1. It says, calculate the gradient of A. What is the gradient of AB? We know the fact that AB is this line, right? I'm going to write it in pink. AB is going to be this line, right? So to find the gradient, of that line, since this line, the inclination is 45, they gave us the angle. We can use this formula, which says tan theta is equals to the gradient, right? We have theta, which is 45, so you're going to say tan 45 degrees is going to be equals to m, right, which is m of AB, right? So therefore the gradient of AB is equals to 1. So the gradient of AB is equals to 1. So question 3.2 says, show that the value of k is equals to -6. Since we know that the gradient of B is equals to 1, right? And we have what? We have the coordinates here, which is the same line, and the coordinate here. The only thing that's missing is k. We can use the gradient formula to find k. So let's do that. So gradient of AB is equals to YA minus YB divided by what? By XA minus X. So we know that gradient is 1, so here we're going to substitute 1, and at YA is what? Is k, so you're going to say k minus YB, which is what? Which is minus 2, right? And this is going to be divided by what? It's going to be divided by XA, which is 4, right? Minus what? Minus 8. So simplify this, it's going to be 1 is equals to, so it's going to be k plus 2 is divided by what? It's going to be divided by -4. Cross multiply is going to be 1 multiplied by 1 multiplied by -4. This side is going to be equals to -4, and this side is going to be k plus 2. Take the 2 to the other side. It's going to be -4 minus 2 is equals to k. Therefore, k is equals to -6. So we're done with the second question. Then question 3.3 says, determine the equation of EA. So let's check where is A. A is this one, right? Since we know that FB is parallel to what? Is parallel to EA. What do we know about gradients and parallel lines? That the gradient of FB is going to be equals to the gradient of EA, right? So what's the gradient of FB? It's here from the equation is this. It's going to be equals to -1/2. Therefore making what? The gradient of EA equals to -1/2, right? So we got that out of the way. So now they say determine the equation. So you know that the straight line equation is equals to y is equals to mx plus c. What do we have from EA? We have a coordinate of a, because we already saw for k. So a here is going to be 4 is to -6. So here what we're going to substitute, we're going to substitute x, y, and also m, right? Because we know that our m is what? It's -1/2. So let's do that. It's going to be -6 is equals to -1/2. Open bracket is going to be 4 plus c, right? We're solving for c. So this side is going to be -6 is equals to, it's going to be equals to -2 2 plus c. Take the negative 2 to the other side. It's going to be negative 6 plus 2 is equals to c. Therefore, c is going to be equals to negative 4. Now, rewriting it as an equation, it's going to be y. It's going to be y is equals to negative 1 over 2x minus 4. And this is the equation for EA. So now let's do question 3.4. The first one, 3.4.1, says calculate the size of theta. So we're looking for theta here. To do that, look at this. We're going to use exterior angles of a triangle. So meaning this, I'm going to shade in this triangle. This is the triangle I'm going to use. So the triangle that I'm going to use is triangle PCB. That's the triangle that I'm going to use, right? So now what can we say about this? When they say exterior angles of a triangle, I mean the fact that this angle, right? This angle is equals to the sum of this angle plus this angle. So it's exterior. So when you add this 2, you're going to get this. That's the exterior angles of a triangle, right? So what do we have? We know the fact that this angle, this one here, which is PCB, which is it's PC, which is we're talking about this angle. That's why it has a cap. B, it's going to be equals to 45 degrees. And your reason is what? Vertically opposite angle. Then now we're looking for this angle so that when we sum them together, we can get this one, right? So what can we say is that we need to find beta first. So to find beta, we know the fact that here the gradient for this line, right? The gradient for FB is going to be equals to a negative half, right? So we need to find this angle first. Okay, so we're gonna say 10 beta is equals to what? To MF. So 10 beta is gonna be equals to negative a half. Then we're gonna say arc10. So beta is gonna be equals to what? To arc10. Then you're gonna say negative a half. And what you're gonna get? You're gonna get negative 26,565. But we want this to be a positive value. So therefore beta, to make it positive, it's going to be 180 degrees minus this 26,565, making beta equals to 153,43, right? So this is the beta. Since if you notice the fact that FB is a straight line, right? To find this angle here, it's angles on a straight line. So let's do that. So to do that, it's going to be BP, which is the angle that we want. C plus what? Plus beta is equals to 180 degrees. And your reason is angles in a straight. Then we already know what beta is because we want BPC. So we want that angle P. So this is going to be 153,43 degrees is equals to 180 degrees. Take this to the other side. Therefore, this angle that we want is going to be equals to 26,565, right? So that's going to be this angle, the one that we want. So it's going to be 26,565, right? Now to find theta, therefore making theta what? Theta is going to be equals to this angle plus this angle. So it's going to be equals to BPC plus what? Plus this angle, which is PCB, right? And your reason is going to be what? Exterior angles of a triangle. Then substitute this and this. So when we substitute, theta is going to be equals to 26,565 plus what? Plus 45, making theta equals to what? Equals to 71,57, and you're done solving for theta. Now let's do 3.4.2. It says find the length of, calculate the length of BF. So where's BF? Let's find it on the, here in the diagram. This is B here, this is B here, and this is F. So this is the line that they want, right? What can we see about F? F is the y-intercept here, and we already have b. So let's find f. So for f, we need to find the y-intercept. To find the y-intercept, the y-intercept is always what? It's always 0 and c from here, from the straight line. So this 2 is c, so our f is going to be what? It's going to be 0 and 2. So that's the point here, which is 0 and 2. So now what we need to do is we need to find the length. So we need to use the formula, the formula for length, which is fb is equals to the square root. So this is the distance formula for finding the length of. So now let's substitute the values. So we know the fact that this is going to be the y, the x coordinate for f, and the x coordinate for b. Same thing, the y coordinate for f and the y coordinate for b. So let's substitute. So therefore fb is going to be equals to 4 root 5 when you punch this into the calculator. So we're done answering this. And then they want us to find the area of ABF. So let's check where's ABF. Let me change the color so that it's a different color. Let's make it blue. They say the area of A, right? So that is the triangle. Let me draw a line. So this is the triangle that they want us to. This is the triangle that they want us to find. The one in blue. What can we see? We see the fact that we already found this one, right? This line, which is FB, and we know the fact that it's 4 root 5, right? So we already have an angle, which is the angle theta here calculated. We can actually use the area rule to find the area of this. So now using the area rule, the formula is half, right? A sine theta, right? So in this triangle, it's always what? The angle in between, then the two sides, which is A and B, is this, the sides that are on the side. So it's the two sides where the angle is in between it, right? So in our case, the area is going to be equals to what? To AB, a half AB, right? Multiplied by what? By FB sine what? This angle, which is angle, right? So that's how it's going to be. So what do we have? We have FB, we have the angle B. What we need is AB. So we need to find the length of A, right? So we need to find this length to complete this whole thing. So the length of AB is going to be the square root of, then you're going to substitute the coordinates. We have A being 4 and -6, and we have B being what? Being 8 and -2. So substitute them inside the formula, then you'll get your value as being 4 root 2. So now you're going to take this and substitute it back into the formula. So now we're calculating the area, which is equals to a half. What's AB? Our AB is 4 root 2, right? Multiplied by what? By FB, which is 4 root 5. Then it's going to be multiplied by sine B, which is the angle B, is what? Is 71,57. Then punch that into the calculator. What you're going to get? You're going to get area as being what? Equals to 20. And then you're done answering this question. So now moving to the last question for question 3, it says, let G be a point in the fourth quadrant. So we know that point G needs to be in the fourth quadrant such that A, right, P, so such that A, P, yes, then B, then G somewhere here, right, is a parallelogram. So let's draw a parallelogram. So this is how the parallelogram is going to look. Let's put in the properties. We know the fact that these two sides are going to be parallel, and also these two are going to be parallel to each other, right? So what they want is, they tell us the fact that calculate what? P, right? A. They want us to calculate P, A, what? Since the cap is at A, they want us to calculate this angle. If I extend this line, right, and I let it go up, and after extending it, and I call this W, right? What can I do? I can actually find this angle, and this angle is going to be vertically opposite here, right? Then we can use co-interior angles because of their parallel lines. So let's do that. So we know the fact that if we extend this line, this one is going to be from here to here. This is going to be 90 degrees. So we can find the remaining here. So to find the remaining for angle, this P here for this one is basically FP cap W. If you follow it, if you say FPWC, where the in-between is, where it's here, that's the angle that we want. It's basically going to be that one plus angle, what? Angle WP, right? PC. So that's what I want. If you add that to WPPC, that's going to give you what? Beta, the entire of beta. From here till here, it's beta. So it's going to give you beta. So we need this one. So we have this one, which is 90 degrees. So FW plus 90 degrees is equals to what? To beta, which is we found to be 153,43. Right, so we need this one, so let's solve for it. FPW is equals to what? It's going to be equals to 63,43. Right, so now we know what this angle is. So this angle is going to be what? 63,43 degrees. But this angle here, let me do it in green. This angle here is vertically opposite with this one. So this one is also 63, what? This is also what? 63,43. Because that's vertically opposite angles. Let's write it down. So we know that angle APPB is equals to 63,43, and your reason is vertically opposite angle. Then moving to the last one, because we want this. To get that one, if we take G, right, if you take this angle that they want, which is P, which is PAG, right, plus this angle, which is APB, that is going to be equals to 180 degrees. And reason why is co-interior angles. Because what? Because of PA is parallel to, what? To BG. Because they told us that is the parallelogram, right? So now we need to solve for the one that they said they want. So PAG, this one we know what it is. It's 63,43 is equals to 180 degrees. Take it to the other side. PAG is equals to 180 minus 63,43, making the final answer to be what? It will be 116,57. So that will be the angle. Then we're done with question 3. So for question 4, it says in the diagram below, S is a point on the x-axis, a circle centered at S, right? And a circle centered at M are drawn. So we have two circles. The two circles touch each other externally at E. FE is a common tangent, so they tell us the fact that this is a tangent to the circle at, right? And they say the circle centered M is having ER as a diameter, touches the x-axis at P. Then 4.1 says the equation for the circle centered at S, so they're talking about this one, is they give us the equation of the circle. So the equation of a circle they gave us for the small circle is going to be x plus 8, right? All squared plus y squared is equals to 4. Then 4.1.1 says write down the coordinate of S. What's S? S is the center. Let me write the standard equation for the circle so that you can see how to get the center. So if we have x minus a all squared plus y minus b all squared is equals to r squared. To find the center, the coordinate is going to be what? The center coordinate is basically equals to a. You change, if it's negative a, it becomes positive. Then if it's negative b, it's going to become what? Positive. So it's going to be, right? So that's going to be the center, how you find the center. In our case here, our a is what? Is 8, is positive 8. So is the coordinate is going to be negative 8. Because of its positive, it becomes negative when you take it out. Here it does not have what? It does not have a b, so therefore by default it's going to be what? It's going to be 0. So that is going to be your equation for the center here. Then 4.1.2 says show that the diameter of the circle centered at S is equals to 4 units, right? So the diameter here are, to find the diameter is made out of 2 radius, right? So diameter is equals to 2r. So we need to find r. What's r? R in our case is here, right? So in our case, so we need to find r. So r squared is equals to what? To 4. So now we're solving for r. R is going to be equals to 2 because we're going to square both sides and it's going to give us 2. So we know the fact that r is 2, so let's substitute it. So it's going to be 2 multiplied by 2, and therefore the diameter is going to be equals to 4, answering this one. So now let's move on to 4.2. It says if it is further given that SR, so SR, let's label it SR, right, is equals to 8 units, and R, they give us the coordinates for R, which is negative 8,5 and 24,5. Right, then the first one, they say find the length of M, so we need to find, right, so what do we know, right? We know the fact that here the radius, right, is equals to 2 because we have calculated it from the equation here, right? We found R from using R squared, which is 4, therefore R was equals to 2, so this is 2, right? So we want, what do we want? I'm gonna do it in green. We want EM, so we want this portion, the small portion. What is the small portion? Is made out of what? The radius of the big circle. So we need to find the radius of the big circle. So this whole thing, SR is equals to 8 units, right? I'm gonna get what? I'm gonna get ER, which is what's ER? ER is the diameter of the big circle, right? So therefore 6 is equals to ER. Then you know that the formula for the diameter is what? Is equals to 2R. So we know that the diameter is 6, right? And we want R for the big circle, so we're gonna divide both sides by 2. So it's gonna be 6 divided by 2 is equals to R. Therefore R is gonna be equals to what? Is equals to 3. Therefore, since EM is our radius, therefore EM is equals to 3. So that's how we found. Then now 4.2.2 says calculate the gradient of the tangent F. So we need to calculate what? The gradient of F. So, but what do we know? We know the fact that S, right, SR is going to be perpendicular to what? To F, tangent perpendicular to radius. It's a property, right? Since these two are perpendicular to each other, right, we can find what? We can find the gradient of SE, right? Then use this property to basically find the gradient of what? Of FE. Because what do we know? We know the fact that the gradient of SR multiplied by the gradient of FE is equals to -1. When two lines are perpendicular to each other, the gradients, when you multiply them together, you get -1. So using that, let's find the gradient of what? Of SR. So we have the coordinate of S, which is what? Is -8 and 0. And the coordinate of R they gave us, which is what? Which is -8/5 and 24/5. So the gradient formula is this. Substitute the values. Then when you punch this into the calculator, what you're gonna get? You're gonna get 3/4. So now we're gonna put 3/4 here, multiplied by MFE is equals to -1. Then we're gonna divide both sides by 3/4 because we want to get rid of this 3/4. Then what? This ones are gonna cancel out, so therefore the gradient of FE is going to be equals to what? To -4/3. So now let's do 4.2.3. It says we need to find the coordinate of, which is the center of the big circle, right? So first thing first, let's construct a triangle and use theorem of Pythagoras to actually solve for this coordinates, x coordinates, right? So if we go down like this, right, from center to the circumference of the circle, this is a radius. So if this is a radius, meaning this one is 3, right? And another thing to notice that whatever x value that we're gonna get here, M and P share what? Share an x value, right? So remember that. So now if we have 3, we can find what? We can find SP. And the reason why we're finding SP because we want the coordinates for P. So let's do that. So we're gonna use theorem of Pythagoras. So if this is a 90 degrees, so the hypotenuse is this one, which is 3 plus 5, which is 5. So this whole thing is gonna be 5, right? Because it's the radius of the small circle plus the radius of the big circle. So it's going to be what? It's going to be ms squared is equals to what? 2sp squared plus m squared. What's ms is going to be 5 squared is equals to sp is the one that we're looking for squared. Then mp is going to be what? It's going to be 3 because it's a radius squared. So this is going to be 25 is equals to sp squared, and this is going to be 9. take the 9 to the other side. So 25 minus 9 is going to give us as 16. So this side is going to be 16 is equals to SP squared. Square both sides, square root both sides. It's going to be SP is going to be equals to what? 2, right? So if it's 4, it's on the second quadrant, meaning this is negative x-axis. This is going to be negative x-axis. So here the coordinate is going to be negative 4 and 0. The reason why it's 0 because of the big circle here at P, at what it touches is the x-intercepts of the big circle. That's why it's 4 and 0, right? So we're done with that. As I said, the fact that M and P share what? Share a x coordinate. So here it's going to be negative 4. Now we need to look for whatever y is. So let me name it y so we can solve for y. So I'm going to clean this off. So what do we need? We can use what? We can use the distance formula to actually find this y. So what you're going to do is you're going to find the distance between M and P, because we know the fact that the radius is 3, so the distance is going to be 3. So let's do that. So we're going to find the distance of M, which is the square root of, then you're going to substitute your values. So we know the fact that MP is equals to 3, right? Then you're gonna substitute your values. So x of M is negative 4, then x of what? X of P is minus 4, right? All squared, plus then y of M is just y, because that's what we're looking for. Then y of P is minus 0. Then the side is going to be what? Let's simplify this square root part. Then the square root and the square are going to cancel out, making y equals 2. So our y is equals to 3, meaning our coordinate is going to be negative 4 and coordinates of M. So now question 4.2.4 says find the coordinate of E, which is this one. Let me do it in pink, which is this one, this point. What do we see? ER is the diameter. We know that. So we know the fact that ER is the diameter. And M is what? Is the center. Is the center. If M is the center of ER, meaning M is also the midpoint of ER. Since we have the midpoint of ER and we have R, we can use the midpoint formula to find, right, the coordinate E. So the center point or the midpoint is what? We know the fact that we calculated it to be 4 end, right? So the formula of the midpoint is going to be x E plus XR divided by 2 is equals to what? To the X value at the center, which is negative 4. And here it's going to be YE plus YR divided by 2 is equals to the coordinate of the center at M, which is 3. Then what's XE? That's the one that we want. Plus XR, which is what in our case is negative 8 divided by 5 is equals to negative 4. This side is divided by 2. Then here YE and plus 24 divided by 5 divided by 2 is equals to 3. Multiply 2 and negative 4 to get rid of the denominator. It's going to be XE. So let's solve for X this side. If we take this negative 8 divided, if you take it to the other side, since it's negative, you're going to say plus, right? Because this one is negative. It's going to be 8 divided by 5. You're going to get your coordinate, your XE coordinate to be 32 divided by 5, right? And now let's solve for Y. Multiply 2 by 3, so you're gonna get YE plus 24 divided by 5 is equals to what? Is equals to 6. Take this 24 divided by 5 to the other side, so YE is going to be equals to 6 plus 24 divided by 5. Therefore YE is going to give you what? It's going to give you 6 divided by 5, making the coordinates of E, therefore making the coordinates of E to be what? To be 32 divided by 5, negative 32. Here it's negative, so here it's going to be negative. Remember this 8 was negative, I made a mistake, so this is going to be negative 32 divided by 5, and here it's going to be 6 divided by 5. So this will be your final answer. So the last question says the circle is centered at M. Then they give us that M is what? M is negative 4 and 3. Shifts, so they tell us the fact that shifts 1 unit to the left. So if it shifts 1 unit to the left, meaning wherever by this coordinate, right, is gonna move. We're gonna subtract it by 1. So this coordinate, so by m, because it shifts to the left, is gonna be -4, -1, right? Then they tell us the fact that the x values and reflects upon the x-axis. If something reflects on the x-axis, it affects what? It affects the y. Which one is the y? Is this one. Since it's positive, it's going to change into be negative. So this is going to be the new coordinate. And they tell us the fact that this thing, we need to name it what? We need to name it. I hope that makes sense. So since it shifts to the left, it's going to affect x. Left and right affects x. So left and right is going to affect x. That's why, and they said left, that's why we added by -1, because it shifted to the left, right? Then they tell us the fact that it reflects upon what? The x-axis. So if it reflects upon the x-axis, it's going to affect y. Same applies if it affects the y-axis, it's going to affect what? X. But now it's reflecting on the x-axis. Therefore, since our coordinate for the x or for the y was positive, it's going to be negative. So meaning this one is going to be what? It's going to be k is -5 is to -3. So that's what we want. So knowing this k value, they say determine whether the point -8, right? So this point, which is the center of the small one, is the center of the small circle, lies inside or outside the center of k. Show all calculations. So what do we need to do? We need to find the distance between this point is S from the small circle. Let me go up and show you. This is the point S, the one that they said determine whether that point lies inside or outside. So that's S, and S is what? Is -8 and 0. So we need to first find the distance between SK and compare it and compare it with the radius of the big circle, which is 3, the radius of this. So SK is going to be this. We're going to use the distance formula, then substitute the values for S and K. Then SK is going to be equals to 3√2, which is approximately equals to 4,24. To know whether the point lies inside or outside, is that, as I said, the fact that we need the radius of the big circle, which is the radius of the big circle is 3. If it lies inside, right, that means that SK needs to be what? Needs to be small. If it lies inside, if it lies outside, SK needs to be big. So since SK, right, is greater than what? Greater than 3, which is the radius of the big circle, therefore it lies where? It lies outside. So therefore K lies outside.